Hello, welcome to Matthiessen State Park, LaSalle County, Illinois. I'm your host, Steve Bauman, and our purpose here today is to discuss the Paleozoic geology of the park. It's a history that stretches back 450 million years to a time when seas covered Illinois. Well, you might be asking yourself, why am I out here when it looks so miserable out? Well, it's New Year's Eve 2010, and it is the first day that has broken 50 degrees for the entire month of December. It's actually ideal setting to do this. I mean, it's a bit foggy, that's the downside, and a little rainy, but deal with that. But the fact that the snow is melting, exposing the rocks, and the fact that we don't have leaves covering the trees makes this ideal to film this today. I'm flying solo today. The bad weather kept everyone else at bay, but that aside, I hope you accompany me on this brief video that describes the Paleozoic geology at Matthiessen State Park. 450 million years in the making. Just south on the opposite side of the Illinois River of Starved Rock, which is far more touristy and far larger, but the real geology is here. All these plants and animals that live here are here because of the geology that is here. And right now we are standing at the sign between the lower and upper dells. And we're here for our first stop because what's behind me here is significant. This sign rests basically on what's called the Saint Peter sandstone, and that's what you have here. Is you have basically three bedrock type units here at the park. You have the Saint Peter sandstone, which is Ordovician. Above that you have the carbonates of the Galena and Platteville, and above that you have the Pennsylvanian strata, which is mostly silts, clays, sands, and coal. The Pennsylvanian is not well exposed here, and we won't be describing it here, but basically starting about 450 million years ago is where the history of this park begins. And my feet right now are basically on top of the St. Peter sandstone, which just behind us is exposed all the way down to the bottom of where the Dells Creek runs. That's about 100 feet below us. But behind me here, these carbonate units with some clays, and these carbonates actually have a lot of sand in them. Just maybe 50 feet that way is more St. Peter, and 30 feet that way, which is north, is more St. Peter. So right here we've got a valley fill on top of the St. Peter sandstone. And this valley fill is what's called the Glenwood Formation. And here in the park, it's represented only by stream channel fills like this one, which actually trends in that direction, which is east-southeast, and actually crops out again in Strawberry Rock. So this is significant geologically because this is an old stream channel. When the St. Peter sandstone was laid down, the seas that laid it down in a barrier island environment similar to what is near Florida today, Destin, Florida area, the seas withdrew. And a little erosion took place, and as the seas came back in, these channels got preserved, these stream channels. And then the seas would deepen again, and eventually we get the carbonates of the overlying Platteville and Galena groups, which we are going to go take a look at right now. Okay, we are now getting close to where the Cascade Falls leads into the stream and meets the Vermilion River, which presently is covered with snow and ice, but it's not a bad day out. We are going to go down to where the two meet in the near area, and we are going to describe the rocks there. Okay, this is looking west into the Vermilion River. As we pan up north, we see these rocks, which we will take a closer look at, which are actually the carbonates of the Platteville, which lies above the St. Peter. Okay, elevation-wise, we are about at the same elevation as the creek behind us was at the first stop. So we are actually about 100 feet lower than we were at that first stop. Now, according to our layer cake of St. Peter, Platteville, Galena, and Pennsylvanian, since we're 100 feet lower and the St. Peter here is at least 300 feet thick, and we know we were near the top of it over there, that we should be in St. Peter. But we're not. You see these carbonate rocks behind us here. And this is the Platteville, right here. And this is probably the Mifflin Formation, the uppermost, if my memory serves me correctly. But if you notice these beds, they dip this way. They actually dip more like this. But basically, they trend almost north-south here, and they dip 20 to 30 plus degrees as you get near the Vermilion River. Now, one explanation would be, okay, these were up higher, erosion knocked them down, and these are out of place, but they're not. These rocks are in their natural position. And since we would expect to find St. Peter here, and we don't, something is going on in this area. And what is here is what geologists call the LaSalle Anticlinorium, which is the largest single structure other than the Sandwich Fault Zone in northern Illinois. And right here is probably the best exposure you can see of it anywhere. And what happened was we had our layers put down, St. Peter, Galena, Platteville, and over time this anticlinorium formed, basically tilting the rocks and bringing our Platteville down lower below our St. Peter. Stratigraphically, it's still above it, but stratigraphically and structurally, it's still above it, but topography-wise, it's not. So these rocks are mostly carbonates. They're mostly dolostone and limestone modeled together. A lot of chert in this. There's also a lot of fossils, which if we can access it, we will look at. And actually, this formation shows a structure called a breccia, because while we had our deposition and the anticline started to form, the rock started to slide a little bit. And this formed some breccia. If I can find an exposure, I'll show it to you. So we know that the anticline started to form when this stuff was initially being deposited. We can lock down a more accurate time of deposition at our next stop, which is actually only a few dozen yards east of us here. Still facing this direction, and it's still Platteville. Here again, you can really see the dipping Platteville beds along the LaSalle Anticlinorium. Okay, we are only about 30 feet from where I just had you at, and we are over here to show several interactions between the Oglesby and the Medusa. Now, here you notice the rocks are still dipping, but they're a little flatter. That's because as you get closer towards the entrance of Matthiessen by Cascade Falls, what happens is the anticline, this is by the river, the Vermilion River, this is near the entrance. The rocks level out. But what you have here is an interesting relationship between the Medusa and the Oglesby. Down here, you have the fine-grained carbonates of the Medusa with these orange-brown laminations. Above it right here, you have those oolitic carbonates of the Oglesby. And if you go up a little more, you get back into something that looks a little more like the Medusa. Now, what happens here is the Medusa and the Oglesby are more intertonguing. The Medusa and the Oglesby intertongue more than they are laid on top of each other. And if you go back towards the entrance by Cascade Falls, the Medusa dominates and the Oglesby almost disappears. And as you go in towards the anticline, the Oglesby dominates and the Medusa here almost disappears. Now, the reason for that is probably because somewhere around this time, the contact between the Medusa and Oglesby right here, right about here, Oglesby and Medusa, is you had your anticline started to actually form. And it was slow and subtle at first, but that led to the deposition from the Medusa here to slightly deeper waters that are more favorable of oolites and oolitic carbonates of the Oglesby. Now, above this you have the Mifflin, above these two members you have the Mifflin, then you have what we call an unconformity. So after this anticline started to form and got closer to the river, got nearer 30 degrees, the seas retreated sometime between the Ordovician and the Pennsylvanian. You don't have any rocks from the Silurian, Devonian, or Mississippian deposited here. West of the anticline in Oglesby, in Oglesby, we have some well data where the Silurian and some Devonian is present. So we know sedimentation continued through then, but after then, the seas retreated and erosion took place. And after a while, the seas, you have your anticline, the seas left, erosion took place, and then the seas came back in and deposited above that, which is poorly exposed here, the Pennsylvanian, sandstones, limestones, clays, and coals. Okay, now we are back towards the Vermilion River, and I have to hand carry the camera. There's where the creek enters the Vermilion River.